This video is recorded to help my students to understand how to estimate population mean when sigma is unknown. Key point is that point estimate of population mean is the sample mean. When sigma is unknown, we will use student t distribution to calculate the margin of error. So formula is this: E equal t alpha over 2 multiply s over square root of n. Here s is the standard deviation of a sample, n is the sample size, t is student t distribution with degree of freedom n minus 1. Student t distribution is close to standard normal distribution, particularly as the degree of freedom go large, is very more and more close to standard normal distribution. So when you calculate t alpha over 2, equivalently you found the t value such that on the right side of this t value, the right tail, the area is alpha over 2, just similar to our normal distribution when we calculate z alpha over 2. After you figure out a margin of error, then the confidence interval will be x bar minus e to x bar plus e, where x bar is the mean of a sample. So let's say an example. The principal random selected 6 students to take an aptitude test. Their scores were 79.3, 81.3, 71.4, 89.6, 89.2, 76.3. First, find the sample mean and the sample standard deviation for these 6 test scores. Then answer how many degree of freedom would be used to analyze this data set. Finally, find a 90% confidence interval for the mean score of all students in the school. Now, if you recall in the previous video, we said that when we want to use this kind of method to estimate a population mean, we have assumption. Either the population is normally distributed or the sample size is greater than 30. Now, in this problem, he did not mention population is normally distributed and the sample size is very small. However, based on our life experience, we know the student test score is normally close, at least close to normal distribution. So we assume this population score is normally distributed. Okay. Now, first step, we need to copy the data to the Excel. So you have 79.3, 81.3, 71.4, 89.6, 89.2, 76.3. You total have 6 score. Then you begin to calculate a sample mean. Sample mean, you will use a method called average method. Then you will just drag through where your data range is, then hit indicate, calculate the average. Now, for the standard deviation, need to pay attention. You need to use standard deviation for the sample, okay? Which is standard deviation for the sample. Then you also drag through this data range, then you hit indicate. This answers the first question. Second question, how many degree of freedom? Well, if your n is 6, then the degree of freedom will be 5. Okay? Of course, sometimes we like to type in the formula, will be better for us build a template for the future use. So the degree of freedom will be the n, which is in J 10 minus 1, okay, which is 5. So the degree of freedom is 5. Now, what is the alpha? Alpha is 1 minus the confidence level, which is 0.9. So your alpha is 0.1. Before we calculate E, we probably want to calculate T alpha over 2 first. Let us calculate T alpha over 2 first. Now, when you calculate this T alpha over 2, you will use this formula. You will use this equal student T dot inverse dot 2T. Now, which means 2 tail. When you use this formula, he asks you for the probability. This probability is not alpha over 2. Since you already say two tails, this probability is two tails area added together, which is exactly your significant level, 0.1. So this will be in my J11, and the degree of freedom will be in my L10. Okay, so together, this is my T alpha over 2. So after we load T alpha over 2, we put it in this formula, we will be able to calculate how much is the margin error. Margin error will be T alpha over 2, which in error 11, multiply sample standard deviation, which is in J9, then divide by square root of n, which is in J10. Okay, so that's my margin of error. Now, after figure out the margin of error, I use this formula to figure out the upper limit and lower limit of the confidence interval. The upper limit equal x bar, which is in J8, plus margin of error, which is in J12. Okay, the lower limit, which is x bar J8 minus J12, which margin of error. So I construct a confidence interval from 75.27 to 87.09. Well, you round up with 87.10. If you have any questions, please give me an email.